the quadratic formula, and the discriminant. Welcome, everyone. Today, we are going to dive into a very powerful topic, the quadratic formula and the discriminant. Now, as we have been studying quadratic equations, you've already encountered several different methods to find the values of x that satisfy an equation. You might remember using factorization, which is a fantastic, quick method when the numbers are simple. However, as you've likely noticed, factorization isn't always possible or easy to find when the coefficients are more complex. That is why today is so important. We are going to introduce a universal tool, a formula that works every single time, regardless of how difficult the coefficients might be. This is known as the quadratic formula, and it will be our go-to method for solving any quadratic equation we encounter. The standard form. Now that we've established that the quadratic formula is our universal tool for solving equations, we need to talk about how to prepare your equation for it. Before you even think about plugging numbers into that formula we'll see in the next slide, it is absolutely essential that your equation is written in what we call the standard form. This means you must arrange your terms so that the equation looks like a x squared plus b x plus c equals 0. Let's break down what these components actually represent. Here, a, b, and c are simply real numbers, which we call our coefficients. Now, there is one very important rule to remember. The coefficient cannot be equal to 0. Why is that? Well, if it were to become 0, the x squared term would disappear entirely, and you'd be left with a linear equation instead of a quadratic one. Finally, x is the variable, the unknown value that we are trying to solve for. Always make sure your equation is neatly organized in this format before you proceed. The quadratic formula. Now that we have ensured our equation is in the correct standard form, let's look at the universal tool I mentioned earlier. To find the roots or the solutions of our quadratic equation, we use the quadratic formula. If you look at the screen, you'll see the formula written out. X equals negative b plus or minus the square root of the quantity b squared minus 4ac, all over 2a. I know this looks a bit intimidating at first glance, so let's break it down piece by piece so you can use it with confidence. First, notice that plus-minus symbol. This is a very important part of the formula because it tells us that there are generally two different solutions to our equation, one where we add the square root and another where we subtract it. Next, let's look at the numerator. The term negative b simply means we take the opposite of whatever the coefficient of x is. Finally, look at the denominator. The bottom part of the fraction, 2a, is simply twice the coefficient of the x squared term. As we move to the next slide, we are going to look at a specific part of this formula, the part tucked inside the square root, which actually holds a special name and a very important property. Understanding the discriminant. Now, if you take a closer look at the quadratic formula we just discussed on the previous slide, you will notice a very specific expression tucked away inside the square root symbol, b squared minus 4ac. This particular part, b squared minus 4ac, is known as the discriminant. Now, you might be wondering why we use such a fancy word. In mathematics, to discriminate simply means to recognize a distinction or a difference between things. We call it the discriminant because its value allows us to distribute or determine the nature of the roots, meaning we can tell if the solutions will be real, equal, or even imaginary, all without having to go through the full effort of solving the entire equation. It's like a shortcut to understanding the behavior of our equation. To keep our work organized, we usually denote the discriminant with the capital letter D, and we define it as D equals b squared minus 4ac. In the next few slides, we are going to see exactly how this value works in a practical, real-world calculation. Real-world application example. Now that we understand the theory behind the formula and the discriminant, let's see how this actually works in a real-world situation. Imagine a scenario where a ball is thrown upward from a certain height. We can model the height of this ball at any given time, which we'll call t, using a quadratic equation. The equation provided is negative 5t squared plus 20t plus 2 equals 0. In this specific problem, our goal is to find the exact time, t, when the ball hits the ground. Since the height is 0 at the moment of impact, we are essentially looking for the solutions to this equation. In the next few slides, we will walk through the step-by-step process of solving this using the tools we just learned. Step-by-step solution. Now that we have our real-world scenario, finding when the ball hits the ground, let's move into the actual calculation. Our first step is to identify the coefficients. To do this, we need to compare our specific equation, -5t squared plus 20t plus 2 equals 0, to the standard form we discussed earlier, which is a x squared plus bx plus c equals 0. By matching the terms, we can clearly see that our value for a is -5, our value for b is 20, and our value for c is 2. Identifying these correctly is crucial, because as we'll see in the next step, even a small mistake here will change our entire discriminant calculation. Step-by-step solution, continued. Now that we have successfully identified our coefficients, that is, we know that a equals -5, b equals 20, and c equals 2, we move on to step 2, which is calculating the discriminant, denoted by the capital letter D. As we saw in the previous slides, the formula for the discriminant is b squared minus 4ac. Let's plug our specific values into this formula. We start with 20 squared, which gives us 400. Next, we multiply -4 by our value, which is -5, and then by our c value, which is 2. When we multiply -4 by -5, we get +20, and multiplying that by 2 gives us 40. So, the expression becomes 400 minus -40. Now, be very careful here, as this is a common place for sign errors. Subtracting a negative is the same as adding a positive, so our equation simplifies to 400 plus 40. This leaves us with a final discriminant of 440. This positive value is important because, as we will see in the next step, it tells us that we are going to have two distinct real solutions for our time variable. Step-by-step solution, continued. Now that we have calculated our discriminant to be 440 in the previous step, we move on to step 3, which is to apply the quadratic formula to find our values for time. Let's plug our values into the formula. We start with t equals -b, which is -20 plus or minus the square root of our discriminant, 440, all over 2 times a, which is 2 times -5. If we simplify that denominator, 2 times -5 gives us -10. So, our equation now looks like t equals -20 plus or minus the square root of 440, all divided by -10. Now, since the square root of 440 isn't a perfect square, we'll use its approximate value, which is 20.98. This is where the plus-minus symbol splits our calculation into 2 separate paths to find our 2 possible solutions. First, let's calculate our first value, t sub 1. We take -20, add 20.98, which leaves us with 0.98. When we divide 0.98 by -10, we get -0.098. Next, let's find our second value, t sub 2. This time, we take -20 and subtract 20.98, which gives us -40.98. Dividing -40.98 by -10 results in +4.098. Keep these 2 values in mind, because in the next slide, we will discuss which of these results actually makes sense in the context of our real-world scenario. Real-world application example, conclusion. Now, before we move on to our final summary, I want to draw your attention to a very important point regarding the results we just calculated. Looking back at our 2 solutions, we found that t sub 1 is approximately -0.098, and t sub 2 is approximately 4.098. Now, mathematically, both of these numbers are correct solutions to the equation. However, we must apply a bit of common sense by looking at the real-world context of our problem. Since we are measuring the time elapsed after the ball is thrown, a negative value for time doesn't make sense in this scenario, We can't have a ball hitting the ground before it was even thrown. Therefore, we must disregard the negative result and conclude that the ball hits the ground at approximately 4.1 seconds. Common mistakes to avoid. Now, before we wrap up our lesson, I want to pause and discuss some common pitfalls. Even if you understand the theory, it is very easy to make small errors that lead to the wrong answer. First, let's talk about sign errors. This is perhaps the most frequent mistake I see. When you are calculating the discriminant, which is b squared minus 4ac, you must be extremely careful with your negative signs. For instance, if either the coefficient a or the coefficient c is a negative number, that minus sign in front of the 4 will interact with the negative sign of the coefficient, effectively turning that part of the calculation into an addition. If you miss this, your entire discriminant, and therefore your final answer, will be incorrect. Second, please ensure you are working with the correct standard form. As we discussed earlier in the lesson, the formula only works when the equation is set equal to 0. A common mistake is to identify your coefficients directly from an equation where terms are still scattered on both sides. You must always rearrange the equation so that everything is on one side, making it equal to 0, before you attempt to pick out your a, b, and c. Finally, pay close attention to the denominator in the quadratic formula. When you are writing out or calculating the solution, remember that the entire numerator, which is negative b plus or minus the square root of the discriminant, must be divided by 2a. It is a common error to accidentally divide only the square root part by 2a rather than the entire expression. Keep these points in mind, and you will avoid the most common traps in quadratic equations. Key takeaways. First, remember that the quadratic formula, which is x equals negative b plus or minus the square to the square root of b squared minus 4ac, all over 2a, is your universal tool. As we discussed earlier, unlike factorization, this formula works for any quadratic equation, no matter how complex the coefficients might be. Second, keep a close eye on that specific part inside the square root. b squared minus 4ac, we call this expression the discriminant, often represented by the letter d. Third, it is crucial to remember why the discriminant is so powerful. As we saw when we were analyzing the nature of our solutions, the value of the discriminant is the key factor that determines the nature of the roots, telling us whether we are looking at two distinct real solutions, one repeated real solution, or even imaginary solutions. Finally, a quick reminder on the most important first step. Before you even think about plugging numbers into the formula, always ensure your equation is written in the standard form, which is x squared plus bx plus c equals 0. If you don't move all your terms to one side first, you'll likely pick the wrong values for a, b, and c, which can lead to those common sign errors we talked about. All right, we have reached the end of our lesson, so let's take a moment to recap the most important points we've covered today to ensure everything is clear. If you have mastered these points, you are well on your way to mastering quadratic equations. Great job today!